Okay, so this video is about arithmetic sequences. And from the IXL, hopefully you realize that essentially it's just a pattern, specifically where you are adding or subtracting the same number every single time. Okay. Um, there are also things called geometric sequences, which is when you multiply the same number every single time, but we're not going to worry about that right now. We are just doing adding and subtracting the same number. Okay. I used to do a whole big unit on this, but really I think it's unnecessary. We aren't even going to have a learning goal on it. I just want to give you the basics and explain how to use the formula that is on the NJSLA reference sheet. So I'm going to show you how to use it. I don't really think you'll see tons of questions on it. So like I said, just getting a very brief overview of it. So a sequence is an ordered list of numbers. Every number in a sequence is called a term. Okay, we use terms for lots of things in math. Expressions or terms added or subtracted together. Here, when we do sequences, we also call those numbers in the sequence a term. So arithmetic sequence, like we said, is a number sequence formed by adding a fixed number to each previous term to find the next term. The fixed number we call the common difference. Now keep in mind, it could be a positive number, which means we're going up each time. The common difference could be a negative number, which means it's going down each time. But whether it's positive or negative, it's just how the terms are changing throughout the sequence. Okay, so for example, 4, 7, 10, 13 is an arithmetic sequence because it is going plus 3, plus 3, plus 3. And notice the dot, dot, dot is there to show it would go on forever. So our next section, we are saying whether or not it is an arithmetic sequence, and we are going to find the common difference if it is. So from 1 to 15, we are going up 14, then 14, then 14. I'm not going to keep writing it each time. In fact, I am just going to erase that, and I'm going to say that this is a yes, and our common difference, which we are going to call D, that would be 14, because it goes up 14 each time. The next one, it appears that this goes down by 13 and then down by 13 and down by 13. So this one does keep going down by the same number each time. So this is also a yes. And in this case, because it is decreasing, our common difference is going to be negative 13. Okay, here it goes from 1 to negative 2, which would be a decrease of 3. But then it goes from negative 2 to 3, which means it would go up by 5. We are clearly not adding or subtracting the same number every time, so this is a no. And our last one, 3, 6, 9, 12, 15, those are just going up by 3 each time. So this is a yes with a common difference of 3. So now we kind of have this weird looking formula. And like I said, this is on the NJSLA reference sheet. But you got to know what the symbols mean and how to use them. Okay, and it looks scary, but it's not. Okay, so what this is saying, a sub n, that's just saying any term we want. Okay, like if we wanted the 5th term, it would be a sub 5. Okay, if we wanted the 100th term, it would be a sub 100. So you would just plug whatever term in you were looking for into that little tiny subscript. And really it's just saying any term we want is going to be calculated using this formula. Okay, a sub 1, hopefully based on what I just said, you realize that this is going to be the first number in the sequence. Okay. The D, I'm going to jump over here because we already talked about that. That is our common difference. Remember, sometimes it's positive, sometimes it's negative. And then we have this n sub 1, okay? This will always be an n, okay? Like that a sub 1, that d, okay? That will be numbers plugged in there. But when we write this out, that will stay an n there. Because what's happening, like if I go back to number 20, okay, like we're starting at 3, obviously, and then we're adding a 3 each time. So we're kind of saying, well, to do our shortcut, which is what the formula is, okay, we need to figure out how many times did we add that 3 on, okay, that common difference. And whatever term we are looking at, like if I'm looking at the 3rd term, which is the 9, we really added 3 2 times to get there. Okay, or if I'm at the fifth term, 15, to get to there, we would have added the 3 4 times to get there. So that's why it's n minus 1. The number of times that common difference has been added to get to your current term is always 1 less than the term number. Once again, you don't have to memorize that. Not super important because you have the formula, but I just want to show you why it's n minus 1 and not just n. Okay. So now, I do want to note also that this is called the explicit formula. There is also something called the recursive formula, and we're not worrying about that because I think this is the only thing that you would really see. Okay, I'm hoping, fingers crossed. Okay, so it's the explicit formula for an arithmetic sequence. So now let's use this. Okay, we got, I'm going to do number 18. Okay, so I'm going to take this information. I'm just going to draw an arrow down here. So I'm using that information, and we're going to use our formula to write our recursive, sorry, not a recursive, our explicit formula here. Okay, so we're going to start with a sub n, because that's what we start with. We're saying whatever term we want. Okay, is going to use this formula. The first term in that one is 77. So we're going to say 77 plus. Okay, we're going to put our n minus 1 because that's always going to be there. And then we said the common difference in that one was negative 13. So I do want to show, whether with parentheses or a dot, it doesn't matter, that there is multiplication there. I can't just write minus 13 because it'll look like you're subtracting 13, not multiplying it. And this is the general setup of our arithmetic sequence. However, a lot of times, especially when you're working on the Math Excel, it will ask you to simplify that, which means we're just going to distribute the negative 13 to both those things. So 77 minus 13n plus 13. And then we can combine our like terms together. So our two constants means our simplified explicit formula would be 90 minus 13n, or negative 13n plus 90. It doesn't matter which way you write it in. And that is our explicit formula for this arithmetic sequence. And we'll do one more. We'll do number 20. I'm going to do that one over here. Okay, so a sub n is our first term, which is 3, plus n minus 1, always the same. In this case, our common difference was 3. So I'm just going to put a 3 on the outside. If you want to put the dot there, it doesn't matter in this case because you are showing multiplication here. And now we will distribute in order to simplify. So we get 3 plus 3n minus 3. And this one, because the first term was actually the same as the common difference, it kind of ends up looking a little weird, a little bit different than the last one, because the 3 and the minus 3 just become 0, and it is just 3n. Okay, that doesn't happen often. Like I said, really only when the first term and the common difference are the same number, but that is our explicit formula for number 20. And if you're like, why are we doing this right now? Okay, it seems kind of a weird thing to throw in with our functions. It does make sense because we've been doing our function notation where it's like I have my function f of x. You don't have to write this down. But we have our function f of x, and then maybe we plug in something like f of 5 into the function. Okay, it's kind of the same idea here. We have something that we're calling a sub n. While it's a little bit different than our function notation, it works the same, where if I want a term, okay, like the 100th term would be a sub 100. So really what's happening here is it's some type of function. The domain is actually just all our natural numbers, because you wouldn't plug in 0. You can't find the 0th term of a sequence. That doesn't make sense. So it'd be all your natural numbers. So a sub 1, a sub 2, and then you would get out whatever function, whatever value from that thing. So just to show you one last thing here, okay, the reason this is useful, okay, like for number 20, the one we just did, if I asked you to find the 81st term, okay, could you sit there and keep counting out your formula 81 times to figure it out? Or like your sequence? Yes, you could. That would take a while though. So once we know our explicit formula, now if we're trying to find the 81st term, that's, a sub 81, we would just plug in 3 times 81 to figure that out, and we would get 243. And that is a lot faster than having to write out your sequence 81 times to get to that number. Okay, so that is the basics of our explicit formula for our arithmetic sequences. And now you will go practice.